Welcome to the Explainer. Now, I want you to imagine, just for a second, looking down at our beautiful blue planet from space right now. You'd see a world in constant motion, right? Every single day, satellites are up there capturing terabytes of visual data, snapping millions of pictures of Earth from orbit, and giving us this unprecedented God's eye view of our home. From that incredible vantage point, you witness the pure, majestic beauty of interconnected biomes. We're talking massive oceans stretching way beyond the horizon, dictating the weather for vast forests that cover entire continents. You see towering mountains feeding fresh water into flowing rivers, nourishing millions of living species. It's a breathtaking, delicate system, all sharing this one extraordinary home. But here's the thing. There's a really sharp contrast between that sweeping, visible majesty and the quiet, creeping degradation happening right on the ground. Human brains actually aren't wired to perceive threats that unfold slowly over decades. So we totally miss the subtle shifts. A glacier shrinking by a few inches a week, a rainforest steadily thinning out, ocean temperatures ticking up by just a fraction of a degree. These changes happen silently, day after day. And by the time our eyes actually register the visible damage, well, the tipping point has often already passed.
Which brings us to a pretty profound question. What if millions of AI agents were watching our planet every single second? What if we had intelligent systems tracking these silent, microscopic changes continuously, year after year? Basically, stepping in as a sort of planetary nervous system to help humanity protect the only home we've ever known.
To understand how that's actually becoming a reality, we have to look at the sheer mind-boggling scale of the data we already collect. Satellites in low Earth orbit are constantly monitoring everything: forests, cloud coverage, ice sheets, crop yields, expanding cities, changing coastlines, massive weather systems, you name it. They are beaming down petabytes of data daily. To put that into perspective, that's more information generated in a single afternoon than exists in the entire Library of Congress. No human scientific team, no matter how well funded, could ever sift through that mountain of imagery manually.
And that is exactly where AI agents step in as the ultimate data organizers. Using advanced machine learning algorithms and computer vision, these systems don't just store data, they actively wrangle it. They're constantly running anomaly detection to spot super subtle shifts, like a change in pixel coloration that might mean a drought or a plant disease. They highlight unusual patterns and alert researchers to hotspots that desperately need a closer look. Essentially, they turn raw noise into actionable intelligence.
Let's make this concrete. Take the Amazon rainforest, for example. It is so remarkably dense and geographically isolated that an illegal logging operation can easily go completely unnoticed for weeks, sometimes even months. In the past, the chainsaws would be long gone and the damage already done, way before a local patrol ever stumbled upon the clearing. But with algorithmic monitoring, that entire dynamic flips. Instead of waiting for delayed ground reports, the AI system is constantly correlating fresh satellite imagery with historical baselines in real time. The very second a new, unnatural clearing appears in the canopy, the system flags the anomaly. It instantly calculates the lost acreage, predicts the most likely access roads the loggers are using, and boom, immediately pings environmental authorities. This triggers a much faster human intervention, often catching the destruction in its early stages before a massive swath of forest is lost. Now, let's switch gears and imagine the world's oceans, because this exact same predictive principle applies beneath the waves. Marine ecosystems are incredibly fluid and dynamic, which makes tracking their overall health a monumental logistical nightmare. The oceans cover over 70% of the Earth's surface. So monitoring the constant, complex variables happening down there requires way more than just a few ships and buoys. AI tackles this by synthesizing overlapping data streams. It tracks rising coral reef temperatures by analyzing thermal imaging straight from space. It predicts shifting seasonal fishing activity by correlating global market data with ocean temperature changes. It can literally even map the drifting patterns of ocean plastic waste by plugging satellite radar data into ocean current prediction models. By synthesizing all these chaotic inputs, scientists can finally map these underwater systems and make data-driven, highly targeted conservation decisions. Back on land, these predictive powers are completely reshaping global agriculture. Think about a farmer managing thousands of acres and the sheer number of environmental variables they have to juggle every single day. One unexpected freeze or a slightly miscalculated watering schedule doesn't just mean a bad harvest for them. It directly impacts global food security.
So, precision agriculture is a real game changer here. AI platforms now constantly monitor localized rainfall, soil moisture sensors, and incredibly complex micro-weather forecasts. They evaluate plant health down to the individual row and precisely calculate irrigation needs. In fact, in some regions, AI-driven irrigation is saving millions of gallons of water annually per farm. By optimizing these exact variables, we preserve water, increase crop yields, and make our entire food supply chain so much more resilient to climate shocks. But, perhaps the most critical application of this tech isn't just managing the natural resources we grow, but how we generate the power we consume. The exact same AI technology parsing satellite images of rainforests is uniquely positioned to revolutionize our transition toward cleaner energy sources. The fundamental challenge with renewable energy is unpredictability, right? The wind doesn't always blow, and the sun doesn't always shine. We are transitioning to smart grids that have to balance hundreds of wind farms, thousands of independent solar installations, and complex hydroelectric systems against a constantly fluctuating real-time electricity demand. That is exactly the kind of chaotic data puzzle AI is built to solve. By continuously forecasting weather conditions and predicting energy spikes down to the millisecond, AI routes power exactly where it needs to go. This makes a fully renewable grid not just stable, but incredibly practical. Now, all of these applications are absolutely incredible, but we need to pause for a second for a reality check. Can an algorithm actually save the world? Can artificial intelligence solve climate change all by itself without us breaking a sweat? The hard truth? No, absolutely not. People make choices. There is a massive gap between detection and action. Artificial intelligence gives us a highly detailed map of the problem, but humans still have to drive the car. Governments have to draft the policies, businesses must invest in the solutions, and communities have to actually adopt sustainable practices. Every single meaningful environmental leap forward depends entirely on human effort and collective will. And this brings us to the inevitable, really complex friction between protecting nature and sustaining economic development. It's never a simple fix. Developing communities absolutely need jobs. Industries require raw materials to function, and cities are going to keep expanding to house growing populations. The math of balancing human prosperity with ecological limits is just not something a machine can solve with a simple binary yes or no. As the saying goes, AI can help evaluate different possibilities, but people must decide which path best reflects their values. The technology can model out 100 different solutions. It can highlight all the economic and environmental trade-offs, but it ultimately steps back. It leaves us to shoulder the heavy responsibility of making the final choice based on our shared priorities. Looking ahead, though, this gives us a blueprint for an achievable, sustainable future. Just imagine an Earth protected by an intelligent planetary monitoring system, forests observed continuously for illegal activity, wildlife habitats monitored responsibly to prevent poaching, freshwater resources managed with extreme efficiency to prevent drought, pollution identified right at the source, and natural disaster risks predicted days earlier than ever before. It's a world where our scientific understanding expands exponentially, turning technology into the ultimate caretaker's tool. There's a thought I want to leave you with. Perhaps the greatest achievement of AI won't be creating smarter machines, it will be helping people make wiser decisions. Earth doesn't just belong to us right now, it belongs equally to all the generations that will inherit it. The true purpose of environmental AI is to empower us to preserve every river, every forest, and every species as a lasting legacy. Every metric ton of carbon reduced, every acre of land saved is part of that legacy. Because in the end, there is only one Earth. Artificial intelligence has given us the ultimate mirror to see exactly what we are doing to our planet in real time. So the only question left is, will we like what we see enough to actually change it? Technology is our most powerful partner for sure, but protecting our world has always been and will always remain a fundamentally human responsibility. That wraps up our deep dive into planetary monitoring. But next time on The Explainer, we are going to explore an entirely different and, frankly, mind-blowing frontier. Can AI agents become actual inventors? Could they help humanity design and build technologies, medicines, and materials that don't even exist today? If you enjoyed this explainer and want to discover how AI is shaping the future of science, sustainability, and our planet, I highly request to subscribe to my YouTube channel and turn on notifications. Join us for the next episode because the future of Earth depends on the choices we make today. See you next time.